Okay, good morning. Welcome to
FamilyMath968.
FamilyMath968. So we're doing problem number 9 in Mosteller's 50 Challenging Problems in Probability today. And this is about the game of craps. Have you heard of this game before?
Oh, yes, I have.
Okay. The game of craps, played with 2 dice, is one of America's fastest and most popular gambling games. Calculating the odds associated with it is an instructive exercise. So now we go to the top of the page here. Ryan? Scoot over.
A little more. Yeah, there you go.
The rules are these. Only totals for the 2 dice count. The player throws the dice and wins at once if the total for the first throw is 7 or 11. So if you throw and get a 7 or 11, you win.
Yep.
Loses at once if the total is 2, 3, or 12. Any other throw is called the point. If the first throw is a point, the player throws the dice repeatedly until he either wins by throwing the point again or loses by throwing a 7. What is the player's chance to win?
All right.
Okay, do you understand this problem?
Yes.
Okay, so I'm going to zoom out back to the whiteboard here. And why don't you write down some of the things that we're going to need to think about in order to solve this problem.
So we're gonna roll 2 dice and
Okay, good. You're on screen there.
3 outcomes. So if we throw, is it a 7 or an 11?
We win.
11 is a win. If we throw
2, 3, or
2,
12.
3, 12,
We lose.
we lose. And then if we throw anything else,
We have to roll until we get that number again, or we get a 7, and then we lose.
so
There's some dice.
we win by, so we get a number here, and then we lose by throwing a 7. And then we win by getting our number again.
Okay.
And then anything else just loops us back here.
Okay, yeah, that's great.
That's kind of how it goes.
Okay, so yeah, that's a nice way to think about it. I got to adjust the camera down a little bit. Okay, so tell me some of your thoughts on this game.
Well, it seems like we can pretty easily calculate these 2 scenarios.
Okay.
And then for the middle scenario, we might just have to... Well, we have to calculate the probability that we throw every other number. And then from there... we can't do every sequence because it's a loop. It could loop forever.
Yeah.
Which is difficult. So we might have to look at, like, what the probability sort of converges to for all the other numbers.
Yeah, this one, right. You've highlighted the difficulty here. So this path, pretty straightforward.
Yep.
This path, pretty straightforward. This path is a little trickier. But we're going to see if we can see. It's kind of a weird thing here, right? Because you have a number like 8 might be one of the numbers we have in here, right?
Yeah.
Okay, so then we're trying to figure out, basically we start from scratch here. What is the probability that if we're rolling two dice, that we roll an 8 before we roll a 7?
Alright.
So give me your thoughts on that problem. Like how do you think you would approach that problem?
I mean, we don't.
I rolled a 7.
Well, I think we can calculate, like, the number of ways you could roll a 7, or the number of ways you could roll every die, and then figure out the probabilities, like, sort of from there.
Okay. Yeah.
Well, we could run that computer simulation and see how many times we get 8 before 7, and see how many times we get 7 before 8.
Yeah, actually this will be a good one at the end of the discussion here to do a computer simulation. So why don't we dive into this now, and I guess rolling these sharp casino dice on our whiteboard was not a genius idea, but it's alright. It's going to get dinged at some point. Okay, so let's go on to solving the problems.